Peter. So welcome again. In this afternoon, we're gonna do our very last lecture for software engineering, and today we're gonna discuss a little bit about your final exam as well. So I'm gonna share my screen with you, and this is our very last topic in this course, which I'm gonna cover it all today. It's a relatively short topic focusing on the system implementation, which means that you have presumably done or interactively doing the design and the specification steps, and the implementation is actually converting all those designs, that whatever you designed and defined in the specification, into actual code. Okay, that is the definition of the implementation. It is the stage in the software engineering process where an executable software is being developed. And this is obviously supported with activities, which is interrelated with activities called software design, which is basically how you're going to develop the abstract model of the system, something that we already discussed in the previous lecture. So that is our topic for today. And we will also, I'm going to also discuss the final exam and how this is going to be done. The final exam date is now available on SIS. So if you actually go to your SIS, let me just connect to mine, you should be able to see the exam schedule right now. So if you go to my exams, I only see mine, and I can see on the list that our exam, which is 314, the final exam will be done on 11th of this month, which is like basically in 9 days. So that will be like more than a week time for you to get prepared, and the exam will be in the morning, 10:30, as you can see on the list. Okay. So this is how it's going to proceed. I'm going to also explain the exam structure. In the exam, you will have 20 multiple choice questions. So every single question will be multiple choice, so you don't have to write anything. And basically, once you have answered the questions, the exam will be done, and I will announce the results. You also have a submission today that you must do. Make sure to do it on time, or otherwise I will not accept your work, or you will heavily be penalized. So make sure the submissions are done on time. You know how strict I am about the submissions. I don't like laziness or late submission or excuses. I like solutions. So please do your work on time. So let's go back to the subject for today, which we're going to discuss. As I mentioned previously, implementation is the stage where the software engineers produce an executable solution for all these abstract models that they have developed. It is in this stage the software is running, and it is highly supported with activities that are interrelated, such as system design. And in some cases, especially in agile development, this is also supported with specifications. So rather than being separate activities in agile development, the design, the implementation, and also specifications run as concurrent activities. In the implementation, you realize the design as a software application. Now, one of the key patterns in software design and implementation are what we call as design patterns. Design patterns are reusable abstract knowledge about a problem in terms of programming code. So you can basically use this to produce solutions to very specific problems. Design patterns are designed basically in a sufficiently abstract way, but the idea here is to reuse them, okay? So any kind of software implementation where the idea is based on reusing the solutions given, it is can be categorized under the design patterns. This is something very important, especially if you plan to graduate this year and get a job, because many of the applications I see on LinkedIn, I go to LinkedIn, as I told you, to job vacancies and also other websites such as Indeed every single week and look at the jobs in software engineering. And particularly for jobs that look for full stack developer or object oriented programming, they look for design patterns for someone who has experience or knowledge in design patterns, because this is like seen as a beneficial thing. Basically, a design pattern, once again, is a software solution designed as a reusable way, reusable code to address specific problems. They are very closely related to object-oriented programming. So many of the design patterns you see in software world will be highly interrelated with object-oriented characteristics. That's why patterns usually make object-oriented characteristics such as like inheritance, polymorphism, and so forth. I will even go a little bit step further and tell you that majority of design patterns are actually related to software architecture as well, such as you will see the observer pattern here, and the observer pattern actually very closely related to a model view controller, for example. The whole idea behind the observer pattern is actually to establish a model view controller architecture. So these patterns are basically designed for specific, designed as specific solutions for problems. So they are written as abstract classes in programming languages. So you fill the details and you address the problems. One of the important features of design patterns that they are not finished, hence why we call them abstract solutions of code. And they can be actually transferred to any source code or machine code. So they are like a pseudocode solutions given to you, and many of the details are left there. So it's up to you how to take it up and which language to use and fill those details. Their purpose is not to give you, a copy-paste solution to a problem, but rather enlighten you about how you can approach to certain problems, how you can solve it, and so forth. That is the focus of the design patterns. They provide a description or template on how to solve problems that can be used in many different situations. And they are formalized practices that usually programmers follow to address problems. There are many design patterns that can reach out, but one of the most common examples I see is the observer pattern. The observer pattern is also mentioned in the book, so I'm not quite sure how many of you are still reading the book, but at the beginning of the term, I told you to get the book and read the chapters as we go along. And I'm pretty sure observer pattern is being discussed there as well. This is a common and well-known example of design patterns. So it's like whenever design patterns are mentioned, observer pattern is one of the common ones that being discussed. As I told you, it is a very closely related to model view controller architecture. So at the core of the observer pattern is to catch up or represent a model view controller design. It actually influenced by encapsulation in object-oriented programming. So many other design patterns, while they are very related to object-oriented programming paradigms. And the idea here is to separate the display from how it is interacting with the objects. So basically, the observer pattern aims to separate the display or state of an object from the object itself. So you can generate alternative views for that specific object. Basically, the idea behind the model view controller is what you can achieve using the observer pattern. So for example, if you have some data in your table and you want to show, let's say, the sales or the success rate of students this term, there could be many display options for you. You can display it with a pie chart. You can display it with simply numbers. You can display it with using bar graphs and so forth. It's up to you how to display it, but regardless of what you could display there, the data will always be more or less coming from the same data set. So it's not like it's going to be a different data. It's just going to be a different view of how to show it. So this is your data. And using your data, you can achieve to this view using bars or a pie. So the how to display this has nothing to do with the actual storage of data. So what we do here, what the observer pattern tells us is that we need to somehow separate this from how it is stored. And what it does is that the observer pattern tells us that you should have an observer class as the abstract class, and you should create a concrete class which extends the observer class so that each concrete observer will be a view. So that is the idea to how to reach this. So this is your abstract class containing the information directly from a data source, and each view on the top of this is actually a child of that class. So this is going to be a concrete class, that is also going to be a concrete class, and they will all extend the actual data class. So that is actually giving us the hint of how to design our application. So if you look at this, you will see how it is structured. So you have an observer pattern, observer class, which is actually an abstract class. And I know this from how it is written down, italic, as you can see. And there is the concrete class, which basically contains the object state itself, which is coming from the observer, and then updates it on the top of it, which is how to display the object. This might sound a little bit peculiar to you because especially if you didn't take an object-oriented programming class, or you might want to revisit that information. But the whole idea behind the observer pattern here is to basically use encapsulation and inheritance. By using inheritance, you extend one class, and using the encapsulation, you hide the details from one class to the other. And it shows you how you can achieve the model view controller design. Using the same data set, you can show the data as a pie chart or a bar. To understand design patterns, you must have a good knowledge in object-oriented programming. If you don't have a good object-oriented programming, you will basically struggle in the implementation part. So majority of the people who will hire you today, they will assume that you have an excellent knowledge in object-oriented programming. And sometimes this is not even mentioned in the job vacancies, because it's like basically you must know English when you join to a company, an international company. They will never actually say that, but if you don't know English, like they will not even consider your application. So this is like kind of like the same thing. Just as you speak English, you must have a very good knowledge in object-oriented programming if you're going to be a software engineer, or otherwise many of these concepts will not make sense to you. This is also another reason why I keep my object-oriented programming class as a prerequisite to this course, because if you don't know object-oriented programming, it might be very difficult for you to understand design patterns. Like if you don't know how to recognize an abstract class or a concrete class or inheritance or encapsulation, it could be very difficult to understand the idea behind this. Any questions so far? Nothing. Someone has a question. Okay, James, you can talk.
I like just want to ask on the things that you just said about the object oriented programming. I didn't really understand.
I don't really understand either. If you are not, you haven't completed an object-oriented programming class, you shouldn't be here because this course has a prerequisite for object-oriented. We provide you this course. I teach the course actually. It's called object-oriented programming, and it is taught with Java. And you should always take this course after you complete that course, not before. Okay?
Okay, sir. Okay.
So if you haven't done that and somehow this course is given to you, you need to talk to your advisor because that's against the school regulations. Okay? You must have you must complete the object-oriented programming class before you take software engineering. That is a must. Okay? Just like you take math 2, calculus 2 before after you complete calculus 1. You take physics 2 after you complete physics 1, right? It's the same thing. You should take this class after you complete object-oriented programming because I'm not going to explain you what is encapsulation, what is inheritance. This is the subject of another course, all right? But basically, I'm explaining you what are design patterns, and if you want to learn about it, you must know object-oriented programming. When we design the patterns, we need to recognize that any design problems that you are facing may be associated to one or more design patterns. And this is why companies are actually encouraging you to look at these design patterns because there are certain patterns in business that can be solved with using these design patterns. And if you don't know them, if you don't know how to approach the problem, the company is not going to waste their time to teach you because that's not a university like in here. They care about how fast you and right you can complete the job. They don't care about teaching you anything because you should already know when you join them. Okay, so many companies will not provide you the training service to learn design patterns. So it is a very good idea to actually recognize them before you join the business. Observer pattern, as I told you, is used when more than one display formats are needed in design. And today we live in an age of smart devices where people can use any smart device to access to the internet, and if they want to access the information you list them, the view should adapt to the needs of the device, such as the resolution, how fast it is, what browser it uses, and so forth. So 20 years ago, you could get avoid of learning design patterns and still find a very good job. But today, that's not going to be the case because if you want to be a full stack developer, you must understand that how these data will be modeled itself to different views so that the data can be customizable. The views can be customizable. It's called responsive design, and I'm sure you have heard of it at some place when you take these courses and so forth. Just to repeat, design patterns are usually problems. They are recognizing the problems of the industry, and usually there is an association of a design pattern to a specific problem. Are there other software design patterns? Yes, many other software design patterns exist, and we can have a look at them in here. Some of them I just listed in here. Facade pattern tidy up the interfaces to a number of related objects that have often been developed incrementally. This is particularly important when you want to maintain the software and gradually develop it. Iterator pattern provides a standard way of accessing the elements in a collection. And can be very useful when you deal with sets of data that you have to do the same operation on them, particularly if your data set is large. And decorator patterns allow for the possibility of extending the functionality of an existing class at the runtime. This is more about optimization of a software. So I would say this is a rather than later stage design pattern to basically make your program function faster, more optimized, and so forth. As you can see, each of these design patterns are focused on solving a problem, but they are regardless very abstract. So many of the details are missing inside. It will just show you how to approach to a problem, but it's not going to tell you how to solve it. It will just demonstrate, like in the observer pattern, a specific idea, such as make the observer the abstract, extend it so each view can be a concurrent class, and that's it. But you have to fill inside what's in the update or the observer state and so forth. There are many implementation problems about generating an executable version of a software, and some of these should be your principles to make sure that you can deal with the problems in the right way. Most implementation problems exist through lack of knowledge or skills in programming. So majority of programming will be actually Googling and understanding how to solve a specific problem. If you don't know how to do it, then you must have the capability to teach to yourself. Nobody is going to hold your hand or spoon feed you. You don't have the luxury to be lazy. You got to sit down and teach to yourself, have that capability. And every engineer should have this feature before you join to a company to work. One of the things that you should always consider is reuse in programming. The modern softwares that we develop, basically, they try to reuse existing components as much as possible in the most optimized way. If there is a solution out there and that is optimized to solve that specific problems, you should not shy away to use as much as possible the existing code. This does not mean that copy paste someone else's code and just use it. But if there is a pattern out there to solve a specific problem, or even a plugin or a library, why not use it? Okay, if it's there done, you don't have to do it from scratch. So many of these solutions in the software world rely on existing frameworks or libraries. Configuration management during the development process, you have to keep track of many different versions of each software component so you can revert back. You kind of like have experience about this now because you did an assignment on GitHub. You know how to use this repository software and also combine with other software. So you can kind of like work on different parts, keep different versions, and combine the software all together. Finally, host target development. Production software does not usually execute on the same computer as the software is being developed. So you can use a very powerful machine to develop a specific software, but not all the users will have the same, such as you develop a specific app on a computer, but the app will be used on a smartphone. So the smartphone is never going to be as powerful as the computer. So it is always a nice idea to focus on the end user who's going to use the software. What do they have, and optimize the software according to the environment or devices that they will access to this specific implementation that you are building. Luckily, you have some help at your disposal, such as specific tools that you can use to address some of these problems. Many IDEs today that we use, integrated development environments, support the development of software with some common frameworks, user interface, plugins, and even GitHub features. Majority of the IDEs you use today have plugins that you can simply install on them that can work with all the software that you look for, such as project management software, GitHub, or even Kanban specific software. So many of the software can also recognize your syntax errors that you can make during the development. Okay. In later years, the idea of open source development have been taken upon in our industry. So open source development tools and languages became more and more popular and supported in the industry. And those software that require, or let's say pushing the agenda of, having a specific certificate or something like that, a license to use them, are basically losing their popularity. So open source development is probably one of the most crucial approaches in software development, and it is based on the idea of developing software code that will be published and be invited by volunteers to participate in a development environment. And it is also making the software available for free of charge, at least for the basic and community editions. And many of the software that we use today are actually embracing this idea. And those that are pushing the agenda of a license, they are losing their popularity. Like back in the days of, let's say, up until 2010, 11, I never was a big fan of C# or Microsoft because of their pushed agenda of paying the system and making their products explicitly, exclusively to their own devices and operating system and so forth. But in the later years, last 5-6 years, Microsoft have changed their agenda completely, and it became one of my favorite companies actually in the world. Every single step that they take in the software industry is I think it's in the right direction, and they're just becoming a very developer friendly company. And when I look at Java, which was my favorite language 10 years ago, now it's just not so much. It became not very developer friendly. It became like very hard to be supported right now. The license issues between Oracle and Google cause a lot of problems for Java to become the dominant platform in the Android. And now Google moved to a different programming language called Kotlin in Android platform, and they're majorly supporting this language, and it's actually working. So people who used to program in Java now moving to Kotlin because they find it more friendly, and the support is getting bigger there, even though it's small compared to Java. It's just Google taking this agenda because basically Oracle forced Google to license, and it just if you become a developer for that specific platform, you are not free to use Java anymore, which is not something desirable. It causes a lot of problem. This bureaucracy, this politics in the software world actually decide which languages becomes popular and which becomes less popular. Open source development, such as in Python, for example, has become the most popular language this year and also the last year. And for the last 1.5, 2 years, Python has dominated the industry. Of course, being open source is not the only reason. because of the trend in the software world, like machine learning. Python has become really, really popular because it's a very developer-friendly environment to code. Like even Gmail today has machine learning. Can you believe it? Like, what the hell? You say that, why would I need a machine learning in a Gmail or like a mail account service? Like, what will it do? But it actually has that. For example, if you are emailing to specific people, like every week, let's say I'm emailing with my project students, and when I add AB to the list, it automatically suggests me to add the C person. Or even if I add someone new, it will ask me, did you mean this guy instead of that guy? So all these patterns, all this user behavior being recognized by the software, at the background, some data is being generated. And according to what you basically do on your machine being recognized. And these software and doing this stuff is not very easy work. You see, there's a high demand for it, and because it's very expensive, very difficult to do. Imagine that you have to pay on the top of that licensed software and stuff like that. So it's just not very profitable to do that. So people will always go for the open source development. And we can see this also in interactive development, like game engines such as Unity and also Unreal has become free and available to many producers, to game developers, app developers. So Unity or Unreal is not only used to develop games, but any interactive software such as virtual reality, augmented reality software, even some services that you use on your phone can be developed using these engines. They are, after all, IDEs, and back in 10 years ago, you got to pay for it. You got to pay for a license to use this software. And nowadays, that's not the issue. They're absolutely free until you come to a certain point to make profit. And then after making your profit to a significant value, then you got to pay for the license, which I think is the perfect way to encourage more and more developers to put their ideas into this industry. I am in the last 5 minutes now. I'm gonna stop in here and re-invite you for the rest of the course. Before I do that, do you have any questions? No. Okay, very good. I'm just gonna go back to BB now, and I'll see you guys in the second half of our course. See you in a while.